So today obtain the state model of the electrical network shown in the figure. Obtain the state model of the electrical network shown in the figure. Okay, look at the electrical network. There is a source E of t, there is a resistance R1, L1, then parallel branch capacitor, then in the second mesh there is an L2, and lastly there is an R2 in the second mesh. So this is the electrical network, and you have to obtain the state space model of this electrical network. Okay, what is state space model is obtaining the equation, mathematical model of this network of the form x dot is equal to ax plus bu. X dot is equal to ax plus bu, where x dot is a vector containing n number of components. If there are n state variables, then x dot will contain x1 dot, x2 dot, etc., xn dot. So that is the concept. Similarly, output equation is y equal to cx plus du. So when we write the state equations and the output equations together, we will get the state model. So we'll start modeling. So first concept you have to understand is how to choose state variable for such an electrical system. One idea is to choose the current through the inductor and voltage across the capacitor as state variable. Current through the inductor and voltage across the capacitor as the state variable. So here you can see, as you can see, there are two inductors. So there will be two inductor currents. So those two will be two state variables. There is one capacitor. So voltage across the capacitor will be another state variable. So in total we have three state variables. Current through L1 is I1, current through L2 is I2, voltage across the capacitor is Vc. So we'll mark those in the circuit. So let us mark I1 of t as the first mesh current, I2 of t as the second mesh current, and Vc as the voltage across the capacitor. The other end of the capacitor is grounded. So Vc is the node voltage as well as the capacitor voltage. Okay. So that part is over. We have chosen the state variable. Next we have to write the KVL equation. To write the KVL equation, okay, the KVL equation will be, how to write the KVL equation? From the first mesh we can write E of t is equal to I1 into R1 plus L1 into di1 by dt plus Vc. So let us refer to the first figure. From this figure, what we can write? E of t minus I1 into R1 minus L1 into di1 by dt minus Vc equal to 0. So from that we get the first mesh equation, that is written as here. E of t equal to I1 into R1 plus L1 into di1 by dt plus Vc. Okay. We note that E of t is the input. So input is usually denoted by U of t. In state space modeling, we have got specific variables to represent the input as well as the state variables. The state variables are represented by usually x1, x2, etc. Now I1 is the first state variable. Therefore replace I1 by x1. di1 by dt will be x1 dot. Vc will be x3. So rewrite this equation. Rewriting the equation as V of U of t equal to x1 into R1 plus L1 into x1 dot plus x3. So first write the mesh equation, and then in that equation replace the variables by the corresponding state variable. Then rearrange the equation so that you will get x1 dot. So from here L1 into x1 dot equal to U of t minus x1 R1 minus x3. Therefore x1 dot is equal to the whole equation divided by L1. So from there you got the first state equation. Similarly, we have to write the second state equation. Second state equation will be when you write the KVL equation 2, you will get the second state equation. So write the second mesh equation. When you write the what is the second mesh equation? Vc of t minus L2 into di2 by dt minus I2 R2 equal to 0. That is the second mesh equation. So from that equation, substitute I2 by x2, di2 by dt by x2 dot, and Vc by x3. Once you substitute that, then rearrange the equation to get the form x2 dot equal to 1. So like that you will get the x2 dot equation. So that will be your second state space equation. Lastly, we need x3 dot also, because there are three state variables. The state equations will consist of x1 dot, x2 dot and x3 dot. So how to get x3 dot? We know that x3 is Vc. So x3 dot will be dVc by dt. So dVc by dt is associated with current through the conductor. So we have to write the node equation. So write the node equation at Vc. I1 as per our current directions marked, I1 of t equal to current through the capacitor plus current through the inductor I2. So I1 of t is equal to C into dVc by dt. That is the equation for current through a capacitor. C into dVc by dt plus I2 of t. Now replace the variables by state variables. I1 will be replaced by x1. C into dVc by dt will be replaced by C into x3 dot plus I2 of t will be replaced by x2. From that rearrange and obtain x3 dot. So once you rearrange and write x3 dot, that will be the third state equation. So now we got the three state equations. Once we get the three state equations, what we have to do? We have to write them in the matrix form. x1 dot, x2 dot, x3 dot equal to, write the coefficients of x1, x2 and x3 correctly. So that into x1, x2, x3, that is missing here. I forgot to write. X dot is equal to a into x, where x is x1, x2, x3 plus b into u. So from the equations we got that only first equation is associated with u. In the other two state equations, the u coefficient is 0. So the first coefficient only is there, R1 by L1. Now we have to write the output equation also. Output equation we can choose. You can choose the output according to your convenience unless specified. So here we will choose voltage across the resistance R2. So I2 into R2. Here I have written R. You can write R2. I2 into R2. I2 is X2. So output is X2 into R. So output is depending only on X2, the second state variable. So write in the matrix form y is equal to Cx plus du. There is no d here. So C matrix will consist of only the second variable x2, that is its coefficient is R2. The x1 and x3 coefficients are 0. So y equal to Cx. So this completes the state space modeling of this given electrical network. Hope you understood. Okay, if there are any doubts, you can put in the comment box.